All right, class. So today is May the 12th, and we're going to do the warm up first. And I'm going to go over the homework. And then after I go over the homework, I'm going to go over scientific notation. Okay? All right. So, your homework for tonight, of course, is to finish the problems in the packet. Okay? All right, so now let's write in our, let's write in our plan. Oh, not that long. Make sure that we have everything written in our planner that we're supposed to. Remember, at any given time, you can stop the video, okay? All right, so make sure you check off if you did your homework last night. Please check off your homework. All right, so Thursday, the 12th, we got Math 8. And our homework is to finish the packet. And please make sure that you review your notes, okay? Okay? Review your notes. Review your notes. So make sure you review your notes on laws of exponents and then what we do today, okay? Please make sure that you do that. Alrighty. Again, anytime you can pause the video. Okay, so I'm gonna do this one. It says convert to standard notation. That means the original state of this number. So this is how you do this. You rewrite the number, and since this is a positive exponents means that your number is going to get larger. Okay? A negative exponent means that you move the decimal so that your number gets smaller. In order for your number to get larger, you have to move this decimal to the right. So you're going to move it to the right 5 times. 1, 2, 3, 4, 5. And you're going to plug in zeros as placeholders. So this is going to be 1, 2, 6, and 3 zeros. So this is 126,000. This is our answer written in standard form, the original form of the number. This is scientific notation, this is standard form. All right, so we're doing from least to greatest, okay? All of this is written in scientific notation. This means that you're moving the decimal 5 places to the right, the number's getting larger. This is 6 places to the right, the number's getting larger. 2 places and 3. Look, the smallest number from least to greatest is going to be the smaller number where it's only moving 2 spaces. Okay, so this is going to be 1, 2. You see that? That's only 720, 720. So I'm gonna write that number. I'm gonna write that number first. This one, 7.2 times 10 to the second power. Okay. Then it's going to be between these two. This one is smaller because it's 6.7 instead of 7.2, and you're moving it 3 times. So this number is going to be 3 times. 1, 2, 3. You see that? 6,700. This one's going to be 7.2. Move it 1, 2, 3. This is going to be 7,200. So this one is smaller. So that comes next. And then this one. Okay? And then the largest one is this one because you're moving your decimal 5 times. See this? 1, 2, 3, 4, 5. That's a lot of zeros. So this is 330,000. Okay? And this is the order from least to greatest. Okay? Pause for the cause. Please make sure you write everything. All right, so now let's look at Thursday. Okay, it says evaluate. So you're going to evaluate this. You're dividing exponents here, but these don't have like bases. So guess what you cannot do? You cannot combine or subtract the exponents. So In order to make this exponent a positive, you move it down to the bottom. So it's going to be 1 on top. Already on the bottom is 2 to the 4th. And then now we have times 3 to now the positive 2. I had to move it down to the bottom. So I have to simplify them separately. Or I'll leave it like this as the answer. If they want it in exponent form or exponential form, then you leave it like this. Okay? But if they want you to simplify it completely, then you have to solve it. So on the bottom, on the top you have 1, on the bottom you have 2 to the 4th. That's the same as saying 2 times 2 times 2 times 2. 2 times 2 is going to be 4. So this is 16. So this is 16 times, we have 3 times 3, and 3 times 3 is what? 9. So now we have 16 times 9. Please make sure you write it, okay? So we have 9 and 6, that's 54. This is 9, 10, 11, 12, 13, 14. So we got 1 over 144. Okay? All right. And then we haven't really done this yet, so let's just hold off. We're gonna cross this. We're gonna cross this out, and I'll do that in a different time. Okay? You can, however, look at this from least to greatest. The smallest. The smallest is gonna have the smallest exponent. Don't forget that if it's in scientific notation. So you got 24, 23 is small here. So this one's gonna go first. Mercury goes first. So I'm gonna write that here. That is 3.301 times 10 to the 23rd power. Okay? That's smallest first. The next to the smallest is gonna be 24 and 24. Look. So since the decimal is moving the same number of times, okay, the smaller number here is the 4. So Venus is second. So that's 4.8. That's 4.867 times 10 to the 24th, and then it's going to be Earth is third. It's the same as it. 5.972 times 10 to the 24th. Let me mark them out. Okay, so next we got 26, 26. These are next. This is the smaller one. Neptune is going to be fourth. So we got 1.0, sorry, y'all. I'm so sorry. Sorry. 24 times 10 to the 26. Okay? Then Jupiter, 1.899 times 10. Okay. Oh, wait. I forgot Saturn. Saturn, that's 26. Exponent's 26 there too, y'all. So Saturn is next. My apologies, this is fifth. So that's 5.685 times 10 to the 26. You see how I'm just really looking at the exponents, how far it goes zero, how far the decimal goes over. And then last, of course, the largest is Jupiter because the exponent here is 27, so the decimal moves 27 times. So that makes it a larger number. Okay? All right, and these are really big numbers. If we had to actually move this 23 times, that's a huge number, isn't it? Okay, so just think about that. All right, so you can go ahead and submit your warm-up because we're done with the warm-up, okay? Make sure that if you didn't finish the other problems, finish the other problems before you submit. And I'm gonna pause for the calls, give you a chance to write. All right, so now let's look at the homework, okay? We already did, this was Monday. We already did Monday together, remember that? So let's look at the Tuesday one. All right, so for Tuesday, go up. For Tuesday, it says LMN. This is L, this is M and N. This triangle can be dilated with respect to the origin by scale factor. Remember, the letter for scale factor is K. K is equal to a half. Okay? So you're going to multiply 1/2 times each of the X and the Y order pairs for each of these. So let's do, they put L prime first. So let's do L first. This order pair here is going to be -3 and we went up 1, 2, 3, 4. Okay. And let's do what's next? M. M is positive 3 and up 1, 2, 3, 4. And N, N is positive 3 and up 1. So now I'm going to multiply each of these by a half, okay? Multiply each of these by a half. So this is L prime. I'll multiply negative 3 times a half. Half of negative 3 is a negative 1.5. Half of 4 is 2. M. Half of 3 again is 1.5. Half of 4 is 2. The scale factor is a half. Half of 3, again, put prime here. Half of 3 is 1.5. Half of 1 is 0.5. So now this is the answer that we're looking for. So that answer is going to be this right here, C. Okay. Let's look at this one. Rotated about the origin. Okay, so let's look. Let's do one of them so you can see what's going on. If I do 1, 1, and I rotate, this is my point, this is X, and this is to be rotated 180 degrees. This is 2 turns, either to the left or to the right, doesn't matter because the picture is going to be upside down. So this is X is 1, 1, okay? So let's rotate it. Look at what's happening. I rotated once, twice. This is upside down. This is going to be negative 1 because you went to the left, and down 1. So negative 1, negative 1. So what? Look at what happened. Both of these changed. The signs changed on both. So X prime is going to be negative 1 and negative 1. Okay? That's where it ended up being. So what do you think it's going to be for Y? If Y is positive 3 and positive 5, then your new Y is going to be negative 3 and negative 5. If Z is positive 5 and positive 1, your new location for Z is going to be negative 5 and negative 1. So the one that we're looking for will be the coordinates of Y. Negative 3 and negative 5. Negative 3 and negative 5. Okay? Deductive reasoning here. Do a simpler one. Do the smallest one. And then look at the pattern and then do the same pattern with the other ones. Okay? If you can't, that's if you can't remember the rule for that. Or use the graph paper and turn it. You're going to have graph paper. This is Wednesday. Okay. So this is look at this. This is a square. And it says to the nearest centimeter, what's the distance from J to M? So we can use Pythagorean theorem because it's a right triangle. This is the side that's missing. So you're going to use the A squared plus B squared equals C squared to solve, to find this side. This side is A, side is missing is B, and the slanted side is C. So we have your A, which is going to be, sorry, this is A. This is going to be 8. Your B is missing, and your C is 13. Okay. So this is going to be 64. 8 times 8 is 64. 13 times 13 is 169. So you're going to subtract 64 from both sides. Okay? This is B squared. Bring down your equal. So this, when you subtract it, and remember, you can pause the video if you need to. This is 5. Okay? And now you're going to find the square root on both sides. So you can use your calculator. You can even use your calculator on your phone to do a square root. The square root of 105. And you're going to put the answer here and round it. One of these should be the answer. Okay? All right. This one right here, it says in the figure, okay, a right triangle. Got right triangle. The right triangle, let's look at which right triangle they're talking about. Start at J, this is J, then go to L, this is L, and then go to K. So they're talking about this big one right here, okay? This is a right angle. This is a right triangle. This is 60. So if you want to figure out what K is, that's easy. You figure out K. If this is 90 and this is 60, the whole thing, all these added together gives you 180 degrees. So you're going to say minus 90, that gives you 90. And then minus 60, that gives you 30. So this is 30 left here, okay? 30 left here. So this angle up here is 30. I'm just saying that. All right, so P is the midpoint. This is the midpoint right here. This is the point that's in the middle between J and K. This is the middle. The segment PQ is parallel. PQ is parallel. This is parallel to PQ is parallel to JL. They're parallel to each other. Okay. All right. Cool beans. Its axis form. The length of segment PK. This is PK. Is 4. So this is 4. So that means this down here is also 4. Okay. So this whole thing right here is 8. This whole thing is 8. I'm just making reasoning as I go along, okay? I may not need all this information, but I'm just reasoning. PQ is 2, so this is 2 right here, okay? What is the approximate perimeter? So all of this is 8. This is 2 right here. So I need to find this length. If I find this length, then I know what this length is, okay? So let's do that. So this is 2, and this is 4. So let's use Pythagorean theorem. This is 2, this is 4. So that's a squared plus b squared equals c squared. We're going to do this side first, so then we can find this one, okay? All right, so we got my a is missing, b is 2, and c is the slanted side, which is 4. So this is going to be 2 times 2 is 4. 4 times 4 is 16. Subtract 4. So when you subtract 4 here, this is going to give you 12. So you have, okay, yeah. So this is the square root of 12. Okay, so this is square root of 12. This is square root of 12. Okay, all right. So this square root of 12. Okay, so now we have to find this side right here. Okay, so we have to find, this is the side of this. Let me find the square root of 12. I'll find those for you so we can estimate that, okay? That's 3.4. So both of these is 3.4. So all together, this side is 8, and then 3.4 here plus 3.4. So look, 3.4 plus 3.4, so you can see it is 6.8. You see that? So this whole side is 6.8. So we're looking for this side here. So do Pythagorean theorem again. Sorry. I've been losing my mind here lately, y'all. It's because I've had a headache for a couple days now. All right, so this right here, this is the C, this is 8. Let's make this is 3, this is 6.8. So we got 6.8, B is missing down here, and C is 8. So let's do 6.8, let's square 6.8, and that's 46.24. So this is 46.24, and this is 64. So subtract 46.24 from both sides. Okay. All right, so let's do 64 minus 46.24. And this is going to be 17.76. Find a square root on both sides. So square root of 17.76, and that's about 4. This side right here is about 4.21. Now the perimeter, let's add all three sides together. This side is 8 plus this side is 6.8 plus this side is 4.21. Add all of these up together. So add 8 plus 6.8 plus 4.21. Oops. Oops. 4, Miss Raines. 1, 2. Okay. Try again. 8 plus 6.8 plus 4.21. Add those together and perimeter. That's what I get. They want the perimeter of this. Oh my God. So this side is 4, okay? This side is 2, and this side is, oh, I did all that work. That's okay, I need to do it anyway. So let's add this 4 plus 2 plus 3.4. Lesson to the wise. Read the whole problem before assuming like your teacher just did, because she is at her doggone mind. And so when you add these numbers together, one of these is going to be about the answer, okay? Pick the closest answer. All right. Add these three numbers together. Okay, the last one. Okay, so this is saying, what is the length of this dotted line here? What is the length of this dotted line? So you have to figure out what, you have to do Pythagorean theorem so I can find, I know that this side is also 5. So if I find this side, then I can just find C, because this is the slanted line of this right triangle. So I need to find this side. So I can find that by using these two legs. This is A, this is B. Okay? So let's use A squared plus B squared equals C squared. We're finding this measurement first. This is my leg, this is my leg. This is the slanted side. You see how this is the slanted side? You see that? This could be A, this is B, this is then the slanted side. So my A again is 6. 6 squared plus 8 squared equals C squared. So this is going to be 36 plus 64 equals C squared. So when I add this together, it gives me 100. And the square root of 100 is 10. So this side is going to be 10. Okay? So now I can find the dash line. Look, this dotted line. This is my A, this is my B. This could be A now, this is B. So we're using 5 and 10. A squared plus B squared equals C squared. So my A again is we got you can do 5 squared plus 10 squared. Doesn't matter, you can either one. They're both legs. So this is going to be 25. 5 times 5 is 25. 10 times 10 is 100. So that's going to be 125. Okay. So to solve, you find the square root. So let's type in the square root. Make sure you pause. Okay. And then one of these is about the answer over here. Okay. So you got C is equal to, find the square root, and that's going to be up closest, choose the best answer. Right. Okay, so we got these points are vertices of a triangle. Approximately, what is the length of RQ? Okay, so graph this. You got 3, 1, 2, 3, and -2, 1, 2. That's this. Then you're graphing 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and -2, 1, 2. Remember, this is P and this is Q. Okay. Then graph 3 and negative 8. Positive 1, 2, 3, and negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And this is R. So this is a right triangle. And you're looking for this length right here. So let's count this side. 1, 2, 3, 4, 5, 6, 7. And then this is 1, 2, 3, 4, 5, 6, 7. Okay? So we're going to use up here a squared plus b squared equals c squared. And the two legs is 7. So this is 7 squared plus 7 squared equals c squared. So see if you can solve this and choose the best answer. Okay? I'm going to erase this so that I can look at the picture. All right, so it's asking for this line segment is graphed here, okay? And this is line segment is graphed. Okay, which could the coordinates of the third z could have an hypotenuse? Don't worry about this one, okay? Don't even worry about it, because you have to graph these different points and do Pythagorean theorem to figure it out. But don't worry about that. Just finish this problem and you can mark out the last one here. Okay? All right, so that's that one. Pause if you need to. And now we're going to do scientific notation. All right, so let's take out our notebook. Remember, this was page 26. Please make sure you paste this down on page 26. And page 26, the title of this page is going to be exponent rules. And if you have to pause, please pause. This is Q4. And this is this was page 26. And it was exponent rules worksheet. And WS stands for worksheet. And that was this, okay? So remember, don't forget, power of a power, you multiply the exponent. So this is going to be B 10 times 8. So that's 10 times 8 is going to be, sorry, I don't know where I get that from, B to the 80. Okay? This you multiply like bases. You multiply exponents to have like bases. So here you're going to add the exponents. So this is going to be 2 plus 10. N is being multiplied 2 times here and 10 times here. So n is being multiplied a total of 12 times. This is another power of a power. Power of power means you're multiplying the exponents. This is going to be 4 times 6. 4 times 6 is going to be 24. Okay, p to the 24th. Again, you're going to add the exponents. So we got 4 plus 3. So that gives us r to the 7th power. This is power of a power, multiply. This is subtraction. Okay, look, this is k. Remember, top exponent first, 5 minus the bottom exponent. This is going to give you a negative 5. You can't leave it as a negative exponent, write it as a fraction. 1 over k, now to the positive 5. Okay? Here, subtract. Top exponent, 9 minus 3. That's going to give you w to the 6th power. Okay? This is u to the 0. Add the exponents. U, 7 plus 0 is going to be u to the 7th. And the last, again, subtract. Z, 7, top exponent minus the bottom exponent. That gives you z to the 1st or just z. Okay? Make sure you paste this on page 26 and then pause if you need to or rewind if you need to. And now we're going to page 27. This is Q4. This is page 27. Please pause if you need to, okay? This is scientific notation. Okay, we kind of talked about this already. Scientific notation is where you make numbers bigger, you make big numbers, extremely large, and extremely small numbers readable. okay? This the whole purpose. Purpose, sorry, is to make large and small numbers readable. Okay. All right, so there are steps to writing numbers in scientific notation. Okay, so we're gonna just jump, we're gonna dive right into it and write steps as we go. All right, so let's start with a really big number. Let's start with 73,000. Okay, let's start with that. Okay, so your first step, number one, these are steps, is to locate the decimal. Pause when you need to, okay? Locate the decimal. If you do not see the decimal, it is automatically behind the last number. So here, this a comma is not a decimal, okay? That commas just help you read the numbers. The decimal is behind the last number. It's right here. So now, the second step, after you locate the decimal, you're gonna move the decimal behind the first significant digit. Move decimal behind first significant digit. Significant digits are digits that hold value, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, single digits is what we're talking about. And the only digit that's not significant is a 0. So you never put the decimal behind a 0. All right, so we're going to move the decimal behind the first significant digit. When we read, the first number we read is the 7. So we need to move the decimal behind the 7. So it's 1, 2, 3, 4. So now the third step is to rewrite the number. Oops. And write, you're going to write times 10, because that's a part of it, okay? So I'm going to rewrite the number. This is the new number. I can put the zeros or not. You don't need the zeros, okay? And then you write times 10, okay? The last step is that exponent is going to be, the exponent is going to be how many times you move that decimal. Exponent is how many times you move the decimal. Okay? I move the decimal 1, 2, 3, 4 times, so the exponent is 4. The original number is greater than 1, so since original number greater, oops, sorry, y'all. Original number greater than 1, okay, it's going to be positive exponent. Super important. If it's less than 1, if that original number is less than 1, negative exponent. The number is going to be a negative exponent. Okay, small number, large number. Okay, the small number, negative exponent. If it was originally a large number, it's a positive exponent. This is larger than 1. So my exponent, when I write in scientific notation, is going to be a positive number. Okay, so there we go. There I go, all of the steps. Okay, this is number 1. Let's do number 2, using these same steps. So number 2, I have, let's do 6, 82375 Okay. I'm gonna put commas in there so you can read it. 6,823,751. First step, locate the decimal. If you don't see the decimal, these are commas, not decimals. Put your decimal, the decimal's automatically behind the last. Now you're gonna move that decimal, after you locate it, move it behind the first significant digit. The first number you read is 6. You see that? You read from left to right. So you're gonna move the decimal behind the 6. So let's count how many times you're moving it. 1, 2, 3, 4, 5, 6 times. Rewrite the number and write times 10. Okay? Rewrite it. And I'm gonna cut it off right here. Okay? I got other numbers, but I'm gonna cut it off right here. Okay, I'm truncating. So we got times 10 to the, how many times did I move it? 6 times. It's a positive 6 because the original number is greater than 1. This is much bigger than 1. So my exponent is gonna be a positive 6. See if you can do this one on your own. Okay, let's do this one. Let's say 82722. Okay, pause for the cause. I'm gonna pause it. All right, let's see what you got. Okay, locate the decimal. Move the decimal behind the first significant digit. The first digit you come to that you read is that 8. So move the decimal behind the 8. 1, 2, 3, 4 times. You moved it 4. I'm putting a little 4 right here. Okay. So now you rewrite the number. This is 8.2722. I'm gonna write all the numbers this time. Times 10, and the exponent, I moved it 4 times, so it's to the 4th. It's a positive exponent because the original number was greater than 1. Let's see if you can do this one. Okay, I'm gonna do this one with you actually. Let's suppose that we have a decimal this time. Let's make a small number, 0.000041. Okay. So when you have a really small number, you do the same thing. Locate the decimal. It's right here. Move the decimal behind the first significant digit. Okay, move from left to right. Look, the first significant digit is going to be 4 still. Because remember, significant, it holds value. Zeros don't hold any value. So I need to move the decimal behind the 4. 1, 2, 3, 4, 5, 6 times. Rewrite the number 4.1, okay? Times 10, don't forget to write times 10. And you moved it 1, 2, 3, 4, 5, 6 times. So your exponent is going to be 6, but it's going to be a negative 6 because the original number was less than 1. It was a small number. Okay. So now let's see if you can do this one. Okay. Pause for the cause. Let's see if you can do that one. All right. Let's try it. So here, we're going to move the decimal behind the first significant digit. The first digit you come to from left to right is 3. So move it behind the 3. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. You got to move it 9 times. Pull a 9 over here so I remember. All right, so we rewrite the number. That's 3.81. Then write times 10, and you move the decimal 9 times. It's going to be a negative because the original number was smaller than 1. This is the number written in scientific notation. Okay? All right. Okay, y'all. Please make sure, please, make sure that you go to the page. There is a puzzle that's on Canvas that I want you to try. Please work on that puzzle, okay? And submit it when you're finished. All right, have a wonderful and blessed day.